Hello everyone. In this video I'm going to go ahead and walk you through the quiz questions that we took recently from our scientific notation and significant figure quiz. Hopefully this will better prepare you for the retake version. As we go through this, you're going to notice that some of the problems are in blue, and that means that they came from the A version of the test, and then other problems that are in red came from the B version. So if your question is not matching up exactly, refer back to the color because you may have the opposite version. Because remember, in between the two quizzes I added some zeros and ones. The first part of everybody's quiz involved putting numbers into scientific notation. Remember that scientific notation meant we put something in the ones place, possibly with a decimal and more numbers after the decimal place, but we raise it to a certain power of 10. The idea is that we want to just get a number into the ones place. So the first way that we do this is we look at this number, and I'm looking for the first non-zero digit number. So 5 is obviously not 0, it's the first one we've encountered, so we're going to put the decimal here. So I need to count over how many places I move the decimal. 1, 2, 3, 4. So the answer here is going to be 5.50 times 10 to the negative fourth. The questions that I've been getting is, well, why do we put the 0 here? Well, remember, according to significant figures rules, the 0 after a decimal is considered significant, so we need to include it in our scientific notation. And the other question I've been getting a lot is, why is this negative here? Well, this original number was smaller than 1, so that means we have to have a negative number, because remember from our discussion of exponents, negative exponents do not mean negative numbers, it just simply means a decimal number. For the next problem here, we look for our first non-zero digit, and it's 1, so I'm going to put my decimal in between 1 and 6. The decimal was originally here, so it had to move over one spot. And so our answer here is going to be 1.6 times 10 to the first. This next one, again, we're going to look for our first non-zero digit number, and that's 2, so we're going to place the decimal here. Again, the decimal was originally here, even though not shown. 1, 2, 3. So we have to move it over 3 spots. So our answer here is going to be 2.012 times 10 to the third. And it's a positive number because 2012 is bigger than 1, so it's a positive exponent. This next one is kind of tricky because you already see the decimal here, but you follow the same rule. I look for my first non-zero digit number, starting from the left-hand side, and I find it to be a 4, so I put the decimal after the 4. Let's count how many places I had to move it. 1, 2, so I moved it over 2 places. So my answer for this one is going to be 4.1999 times 10 to the second. Again, it's a positive exponent because it's a number. 419 is larger than 1. The next part of everybody's quiz involved taking numbers that were written possibly in in scientific notation, but definitely in exponent form, and writing it out into standard form, and that just means long ways. So this first one, notice it's 10 to the fourth, so that means I'm going to have to make the number bigger, and I'm going to move it over 4 spots. So it was originally here, so it's going to go 1, 2, 3, 4. So what I do is I just put zeros here. So when I write this number out, the answer is going to be 3602500. And this is how we write the number in standard form. You can include the commas if you want. So it looks like it's 3,602,500. This next one, now we have a negative exponent, so we're going to be making this number even smaller. So I'm going to move this decimal place over 2 spots in this direction, 1, 2. So here's our new decimal. Add the zeros in. So our answer for this one is going to be 0.00098889, and that's our answer. Notice that now this number is smaller than our original number here in blue, and that's because we've got this negative exponent here, so we're making the number smaller. Now this next one is tricky. This idea here is that whenever it's 10 to the 0, that is the same as saying 1. So all we're doing here is we're going 782 times 1, and hopefully everybody's like, that's just 782. Now this next number is 5.55 times 10 to the fourth. And so in this one, you're basically going to be making the number bigger, and you can tell that because it's a positive exponent here. So I'm going to move it over 4 spots. So 1, 2, 3, 4. Again, in these like little bumps here, like little waves, I'm going to add zeros. So our number here is going to be 5, 5, 5, 0, 0, and I can go ahead and I can add my comma there. So our answer for this one is going to be 55,500. I know identifying the number of sig figures can be tricky with all the rules, but let me just go ahead and try to point these out to you. Number 9 here has 3 sig figs, so these numbers are considered significant. This number right here is the placeholder, so it's not considered important. This next one, though, these zeros here are considered important because they're sandwiched in between two non-zero digits. So in all, that's kind of a big line, we have 4 significant figures here. This one also follows that idea that this is just a placeholder, so this one only has 2 significant figures. Remember, if it did have a decimal at the end here, we would say then it had 4 because we were able to measure all the way out to the ones place if that decimal was here, but originally the decimal wasn't here, so it only has 2 significant figures. Then in this next number, this is kind of a combination of rules. So here this 0 is significant because it's sandwiched between these 2 non-zero digits. This 0 is significant. We talked about this a little bit earlier because it's the last 0 after the decimal. So all of these numbers in here are considered significant. Again, just like in number 9 up here, this one was just a placeholder. This one is also just a placeholder. So this is going to have 1, 2, 3, 4, 5, 6 significant figures for this answer. And I know if you have test B, your answer might be a little bit different, but look at this original number to see how it was different. Okay, this question comes from the B test, and so you can tell because it's in the red ink, so you people with the A quiz might have something slightly different. But the idea is we both tests had the same type of problem. So the important things that I want to mention is when you're entering this into your calculator, you definitely want to make sure that you're including these parentheses here. You may even need to include parentheses around your negative exponents. One thing that I did see some people doing in class was actually just putting parentheses, then another parentheses in their calculator, and you're not going to get an answer that way. So you need to make sure that you're putting the multiplication sign in between there. So when you enter this into your calculator, you're going to come up with a number that's like, 7 point something 5, and I believe you come out with some more numbers after that, times 10 to the negative 23rd. And this is not a bad number, but you want to double check to make sure it's right for your test. So the idea is that you want to be, there's 3 sig figs, 2 sig figs, so your answer can only have 2 sig figs. So that's why your final answer is 7.5 times 10 to the negative 23rd. I did have a lot of people who had some issues on the test with the exponents, getting the correct exponents. Make sure that you're taking this exponent, which I hope you can see now is negative 11, and here's a negative 12. You should be adding these together, so 11 plus 12 is 23, and that's what we're coming up with, and that's just a quick, easy way to double check to see if you have the correct number of sig figs. This next problem is a little bit different in that you need to set these up in what I call the elementary school format. On your test, it was written out long ways. It was to test your ability to write them out in elementary form. So the idea here is you want to solve it just like you normally would. So I'm bring down the 8, bring down the 5. This is going to be 16. So our answer here is 16.58, and that's just our calculation answer. But notice there's nothing here in the hundreds place. So I have to have something, I have to go ahead and round it. So I look at this number. It's 5 or bigger, so my answer is going to be 16.6. And many of you guys did get that, but if you would have looked at the directions, you would have seen that you needed to have written it in scientific notation. So to write this one in scientific notation, our decimals here, I need to move it over 1, because remember we want something in the ones place. So our answer here is really going to be 1.66 times 10 to the first. And so some of you guys wrote it as 1.7 and times 10 to the first, and I should have given you credit for that as well. It can be confusing figuring out, okay, well, is it, I have something in the hundreds place, am I supposed to have it? Am I just supposed to have something in the tens place? So that's why I gave you credit for either answer. Again, this was another problem that was set where you had to set it up in the elementary school format. So just solve it just like you normally would. So 10 minus 7 is 3. You would have already taken 1 away here, so this answer is 83. But then when we look at this 0 is a it's a 0, okay? So that means there's nothing in the ones place here. So our answer can't have a number in the ones place. So I look at the 3. The 3 looks smaller than 5, obviously, so our answer is really going to be 80. But then we run into this problem again of, well, it needs to be in scientific notation. So the decimal's here, even though you really can't see it. We slide it over one place. This is going to be 8.0 times 10 to the first. But then, remember, can we have something after the ones? So this gets a little tricky. So if you guys would have done 8 times 10 to the first, that's the answer that I would have liked to have seen. And so you got credit for if you had something possibly slightly different. And this last one is very similar to the first calculations problem again. It's again important that you're including your parentheses. I kept getting people asking me what this line stands for, and this line means the same as divide. So you want to make sure you're dividing. And then so when you enter this into your calculator, you should come up with an answer that's like 2.83, and you had some more numbers after that, times 10 to the 25th. And again, the idea here is we have 3 sig figs up here. I have 4 sig figs here. You can't really see the decimal, but it's there. 4 sig figs here. 3 is less than 4, obviously, so our answer can only have 3 sig figs. So our final answer is going to be 2.83 times 10 to the 25th. Remember that the directions also said to write it in scientific notation, but this answer is already in scientific notation because I already have something in the ones raised to a power of 10. Remember, if you have any more questions, please stop by after school. I want to help you. I want to make sure that you're understanding this. Have a good evening.